This example is used to illustrate the point that sometimes you get yourself into trouble and then you dig a deeper hole for yourself.
Yeah, yeah. Just
Like,
keep piling code on this problem. Hopefully it'll
yeah,
fix
yeah.
your issue.
One way of explaining that is the sunk cost fallacy. It's like
Hmm.
because I've already committed to this plan, even when things are going downhill, I'm not gonna get away from it. I'm gonna try harder at executing this plan, even when the right thing to do would have been, or the more beneficial thing to do would have been to cut your losses early,
Yeah.
but you still don't do it. And so this is an example in chess where it happened to my opponent, and I can gloat about it a little bit. Um, um, I'm going for this pawn here. Like he originally he had this pawn guarded with the knight, and because he moved the knight away, I decided to attack this pawn because I thought like the reason he wanted to move this knight here is to trade off the knight over here, right? So he's gonna take, and then if he takes, I'm gonna take with my pawn.
Hmm.
And I calculated this up to this point, and I realized that, well, if I take with my pawn is going to be attacking his rook. So he's going to have to spend time moving his rook. And while he moves his rook, I will have time to take this pawn. So I get to win a pawn at the end, right?
Sure.
So that's exactly what happened. So this here, now I'm like, yeah, I get to take this pawn now. I won my pawn because his rook has to move away. But at this point, I think he was in that mindset of, no, I don't want to give up this pawn. So
Oh boy.
what he did was move his rook here. He wanted to attack this pawn of mine. He's like, okay, we're just trading pawns because I'm gonna get you take my pawn. I'm gonna be able to take your pawn. But I at this point I realize, no, I can attack your rook while defending my pawn. So you still have to move your rook away. So now the next move you're gonna move your rook away, and then I'm gonna get my pawn. And that, but that's not what happened. He said, no, I'm gonna guard my rook with my rook. What it allowed me to do is block off the connection of the rooks, and I'm winning this rook.
Yeah.
He just dug himself a deeper and deeper hole. Initially, it was a small loss. He was going to lose this pawn, but became a bigger and bigger loss as
Hmm.
as he kept refusing to concede. And in programming,
You could double down on a bad pattern, or I'm trying to think of like a concrete example I've seen. In this case, he was trying to hold on to that rook no matter what. Sorry, hold on to the pawn.
uh-huh.
Um, and maybe it could be you try an approach to solve a problem and it doesn't really work, but you're like, no, I'm gonna like force this solution through.
Yeah, that reminds me. So oftentimes you extract some reusable function that you can use for certain things. And then when there's problems that it doesn't immediately solve, you add different modes. Like you add an input that is like a mode that
Hmm.
goes into that function. And by the choice of mode, you add some switch statement or if statement inside the component that makes it do slightly different things. And then you keep adding more and more modes to that thing. And then like the right thing to do is just to call it quits and say, this isn't holding up anymore. I should try to find a different approach to it
Yeah.
than simply adding more modes. But I've seen those kinds of code get crazy.
I have one more that I wanted to tell you as well. The parallels of learning, both chess and programming languages have like, not the easiest, but it's a reasonable learning curve to get up and running. So parallels in programming languages, you have learning the basic data structures like variables, objects, arrays. In chess, you have learning the different pieces and how they move, right? You have things like in programming, control flow. In chess, you have the game flow, and the objective of checkmate in chess versus in programming, it's typically to accomplish some kind of task.
Mhm.
However, both of them, while relatively easy to get into, have a tremendous depth in order to master and take many, many hours because there are so many concepts and principles and lurking beneath the surface.
Yeah. Chess is very famous for being extremely complex because of the sheer amount of combinations that you can get.
It's very deep because there aren't all that many things you can do. And similarly in programming languages, to some extent, there aren't all that many structures or pieces you can use. But the depth of it is insane because the variation of what you can do is just so.
Chess is nice for study. Chess is actually more tractable than programming because programming has the subjective element to it.
Yeah.
Both from the product development side and the sort of developer side of things. Even though chess has a psychological side as well, you can reduce it down to just the choices you can make on the board.
One thing I've just observed, like showing people the basics of programming or like the basics of chess, is there's typically this moment where even after they learn, like, okay, this is a function, this is an array, and like this a pawn, this is a bishop. I know what the things are, but there's this moment where they're just like, I don't know what to do. Like in chess, they're like, I don't know what to do. Like there are so many options. I don't know where to go or like what I'm trying to do. In programming, it can be like the same type of thing. Yeah. Like you present them with a simple task and they're like, I don't even know how to begin.
Have you come up with a way to talk to them? I don't know what to say.
It's hard. It's hard. It's really hard. And I think sometimes you have to lead by example. Where I think about when I like ever approached my first algorithm problem of like a reverse a string, I was completely clueless and I had to like kind of dig into some examples. But I think short of that, helping people think about breaking it into smaller steps really helps. You're like, well, what about, we know that controlling the center is good. And if we move a pawn, we can create more options for movement and also make strides towards controlling the center. In programming, it seems like we're going to need a place to put our stuff. So maybe we could create an array, to start. Things like that. Like really small, trying to train people to think in really small pieces and not get overwhelmed at like the prospect of get the king or like write the whole application.
So we have these chess AIs that teach humans how to play better. Like I have a computer acting as my teacher, which is really incredible. That might be coming for programming, maybe at some point.
I could see that.
What I want to say is that there's a benefit in calculating to multiple levels of depth when you're evaluating your choices. Here, the computer is actually telling me knight here is the best move. I couldn't really understand why.
The only thing I could think of is I know like knights are really strong on the 6th rank.
Okay.
But otherwise, there's no immediate benefit. It's just a really good position for the knight.
Are you trying to trade off this bishop? I did consider trading off this bishop.
No, your knight is in a way better position than that. That bishop is really stuck in a lot of ways because of those pawns.
I thought my move was really good. What
was your move?
Pawn up. But the computer said, no, that's a blunder. That's a horrible move.
Really?
Yeah, but I still ended up coming on top. My plan even worked out. It's like, because my plan was like, hey, I want to win the exchange. And so my plan initially was like, I'm going to fork. The rook was here, and if I move my knight here, then I fork these two rooks. And I win one of the rooks. That was my plan initially. And he was like, oh, I see that. So I'm going to move away the rook. I'm going to move the rook here.
Which they also consider a blunder.
Yeah, the computer also thinks, the computer is just better than anybody. So what can you say? It even makes Magnus Carlsen humble. But my plan was like, hey, I'm going to go here. And then what he would have to do is move the rook. And now I have to, I can move my knight here. I'm going to win this rook. Or he's going to have to take my knight with that rook. I win one of the rooks, right? And it worked. And it worked. So he ended up taking my pawn, and now I get to take my rook. And I was happy. It's like, yay, my plan worked. I won the exchange. I won one of the rooks. Why does the computer think this is the best move? You sort of have to see several steps deeper into the position in order to understand it. And the reason is if you make a random move, for example, you take the bishop, take the knight, this is checkmate.
Yeah.
It's like, holy crap. Well, okay, let's say the rook, I don't know, goes here.
Okay.
And then now you take the bishop and you still open up this file and then you check the king. The king has to go here. And then what you do is you check the king again. The king goes here. And then you double up your rooks on the last rank. And then this knight is trapped.
Yeah.
And it's like, holy crap. How many moves do I have to see ahead in order to see that knight move back there was the best move?
I will say though, and I did not see that many moves ahead. This is where I feel that like in both programming and chess, principles can come in handy, because what I talked about before is like, I don't necessarily know what the best thing or why it's the best, but putting a knight on the 6th rank, I know is a smart move. And then here, what they eventually did, doubling up your rooks is very often a very smart move because they're so powerful when they're together. And then so you're like kind of creating opportunities, even if maybe you didn't necessarily see it like an obvious opening right away. It's like if you bring yourself a step closer, then maybe like you're like, oh damn, I can do this. It's like these options present themselves. And similar to programming, if you just like structure things well and set yourself up well, it becomes like much easier to execute future things that maybe you didn't anticipate at an earlier stage as well.
Yeah, I think that's true. It's something that maybe I, haven't really fully appreciated. But yeah, I think that's very true.
The Amateur's Mind by Jeremy Silman. I got that book and I had like a period where I was studying it and going through the examples, and he has like 8 or so very broad principles with like tons of examples. And he's kind of like emphasizing what I'm saying as well. It's not necessarily about seeing like a lot of moves ahead. It's like just knowing kind of like the best practices, if you will.
Oh, is it a chess book?
Yeah, it's a chess book.
Got it.
But anyway, to your original point, Toby, about the deep study, absolutely. Like I like learned how to play chess really young and like just played for fun. Like I've played like a lot of times, right? And it wasn't until like that stint, like in the winter of this past year, like, and you were involved with that too. I was like, I actually like for the first time, like seriously studied the game and like used the chess engine to walk through games and stuff. And it really elevated my game, like in a way that just playing over and over again, but never like going deeper did. It just like, it advanced things in such a different way. So I completely agree. And the same you can apply to programming languages. You can just kind of like get through your day job and like, maybe like do a little bit here and there, but I think it really pays off to like spend some extra time to like go deep into like programming language or programming study.
At a more concrete level, if you look at the calculation of chess outcomes as decision trees, if I do this, they do this, then I do this, but at each fork, there's actually multiple fan outs. What you're trying to go for is a global maximum, like you're trying to go for the optimal move with all of those possible outcomes in mind. And the best move is a move that considers all of those possibilities versus like considering the choices at a superficial level. So like I feel like one of the things we might do is like choose this framework versus choose that framework. That's like a choice at a more superficial level. So like we get these flame war debates about my framework is better than yours or my programming language is better than yours.
Sure.
But that's only the first move of the variation. Regardless of which choice you make on the first move, there's so much more richness that's underneath that. For each program that you write, there's lots and lots of choices you make. Every single line of code you write. How do you make this choice versus that? And if you encounter this, what choice are you going to make? We go about those things. We maybe follow some good rule of thumb that we learn. But also, if you want to make a really good choice, sometimes there's just no avoiding the having to traverse pretty deep in all those options first.
Yeah.
Before you realize what the best choice is at the top level, you know?
And
So
that's what you recommend when you're like, if you're not sure what the solution is, it's worth trying out several and then picking the best one.
yeah, that's what I advocate. Like if you don't know what's the best code structure, it's worth it to try multiple ways to refactor the code.
I have one lightweight one as a closing thought. This is just more of an observation, but I really, in both like the chess and the programming community, I really like how it attracts people from all over the world. Like you play chess online and it's like you never know which country the person's going to be from. You go to like a programming conference and you'll have like attendees from all different nations. I just think that's really cool. And it's like cool to have that thing in common with people that otherwise, you might be pretty culturally distinct or even like speak a different language.
Yeah.
So I really like that aspect.
Yeah, definitely. I like it when I'm playing chess with somebody and I see their country flag there.
Me too.
At the conference. Usually it's not as international. Depends on the conference you go to. Maybe I should go to Europe.
Like the EuroJS Con. It's true. Because like in chess.com, it's like you don't even need to speak English at all. Like and I'm sure many people don't. But the conference, typically like the language is going to be, the common language will be English. Typically attendees will be from like wealthier countries.
Chess is really so universal that you can get to know somebody without being able to speak to them.
Yeah. Real life, I traveled to Bosnia and I was like waiting for a family member to show up for an afternoon. I was like walking around by myself and there were a bunch of old Bosnian dudes in the park playing like a large version of chess. And I was like able to stand by and like watch it. And it's like, I don't know anything they're saying. Or they're in such like a different age bracket than me. Like all that, we're very different, but I know exactly what's going on in this game.